All right, good morning, College Trig, at least this morning when I'm making this video. You should have received via email a take-home quiz over double angle, half angle, sum and difference formulas. And as soon as you get that done, if you can take a picture of that and send it back to me, or, oh my word, I didn't move around enough. The lights just went out. Hold on. So I think it's 15 minutes, if there's not enough movement, the lights go off in this room, so I must not have been moving around enough. Anyway, get that quiz done, get it back to me. Chapter 4, you'll notice I'm going to kind of condense 3 sections into one. And the reason I'm able to do that is because this is all stuff we've cleared or covered before last year in pre-calculus. So the first section, 4.1, is your classic SohCahToa, right triangle, trig ratios. And so, I think we're probably pretty comfortable with this. Sometimes, let's make something up here quick. Sometimes they're pretty traditional. You're given some sort of angle. That's clearly 23 degrees. And, the building, which is on fire, or I don't know what it is 22 feet tall. And then the question is, well, I don't know what the question is, but we're going to find this side. Okay? And so I guess the thing, especially when I first teach this, is for you to think, okay, from the angle I know, what sides do I know? What side am I looking for? Well, I know the opposite. Remember, opposites always go across. Hypotenuse is always across from the right angle, and then whatever's left is your adjacent, essentially. So I know the opposite. I'm looking for the adjacent. You go up to your little saying up here and say, oh, if I'm dealing with opposite and over adjacent, that's a tangent situation. Okay? Opposite over adjacent, which is our question mark. And then sometimes the algebra bothers us. I always, especially with the younger kids, I just say, make it a proportion. Put it over 1. If you ever have 3 of the 4 parts of a proportion, you just cross, multiply, and divide. So I'm going to take 22 feet and divide it by the tangent of 23. So 22 times 1 is 22 divided by the tangent of 23. And I find out that we are standing 51.8 feet away from the burning building. Okay. So like I said, I don't really anticipate this being too difficult a section for you. I guess sometimes the thing that becomes a little more difficult is when you are sometimes asked to find the angle. Like, I don't know this angle, but I know that it's a 8-story building, so we're saying it's 80 feet tall, and we know that, we're standing, does that look bigger? We're standing 95 feet away. Find the angle. Okay. Same kind of deal. I mean, if this is the angle that we're looking at, this would be considered the opposite. This would be considered the adjacent. So we say the tangent of that angle equals 80 feet divided by 95 feet. Okay. Now, the thing I guess you need to remember is if you're trying to find an angle, don't forget to use your inverse key. So there's kind of 2 approaches to this. You could say, well, I know I'm going to go tangent inverse of 80 over 95, and that will give you the angle. But you might say, well, didn't you just say make a proportion and cross multiply and divide? You can do the same thing. 80 times 1 is 80 divided by 95. The only thing you have to be careful about is, remember, that's not the angle. That's the tangent of the angle equals that decimal, which is 80/95. And then to find the angle, you still have to do this thing. So, all right, so section 4.1, the assignment off of section 4.1 is, it starts on page 254. And we're going to kind of not do maybe as many problems, 10 through 40, but we're going to go multiples of 5 to kind of keep things moving along. And then there are a few applied problems, 57, 68, and 77 are kind of applied problems. Okay, so there's your that would be your assignment off of section 4.1, which is your SohCahToa right triangle trig. Okay? And I'll include that assignment in the email I send out. Section 4.2 and 4.3 actually start to deal with what happens if you have triangles that aren't right triangles. Okay? Non-right triangle situations. I probably should have reviewed this in the last section. Remember, capital letters stand for angles. Lowercase letters stand for the sides opposite them. Okay? And when you get into the law of sines and law of cosines, section 4.2 is actually law of sines, and 4.3 is actually law of cosines. Some things that I have kind of stressed in the past. If you ever have an opportunity to find a particular angle first, find the smaller angle first. Find the smaller angle first. If you have a choice, find the smaller angle first. And kind of the reason why is when you go to find an angle, we just mentioned, and when you go to find an angle, you use sines inverse or cosines inverse, or an inverse trig function gives you the angle. And the thing is, if you were looking for this angle, like right here, this bigger angle right here, remember what the sine graph does. The sine graph does this. Okay? And so maybe I said, well, the sine of some angle is supposed to be 0.75. We know it tops out at 1. You know, I want 0.75. And you find that answer, and it says, I don't know, I guess I could do it quick. Sines inverse 0.75 is like 48.6 degrees. And so your calculator says, guess what? That angle that you were looking for is 48.6 degrees. And you're like, no way, that's not 48.6. That's over 90. Well, what you were really after was this one over here. Okay? Which is 180 minus 48.6. But your calculator using the inverse sine key is going to give you that first one. So if you don't find the smallest angle first, and the one less than 90, sometimes you have to think a little more carefully about what you're being shown on your calculator. That's why I say find the smallest angle first. Okay. Now, what is the law of sines? Well, it's simply a little proportion. A is to the sine of A, as B is to the sine of B, as C is to the sine of C. Now, here, actually, I just wrote that down. I believe that's the way pre-calc book teaches it. I believe our college trig book actually has them all flipped. Sine of A over A, sine of B over B. So it doesn't really matter. But and you're not going to do all three at once. You're going to take what you know, and you're going to set your proportion. The key is to get one matching pair. Like if we come back up here and I say, okay, angle A is 17 degrees and side A is 23 centimeters. Okay, that's key. We have the matching pair. And then maybe we know side B is, does that look like less? I suppose it does. So that's 20 centimeters, we'll say. Okay, so solve the rest of the stuff. Okay, so I start with, I'd say, okay, 23 centimeters, that's A, is to the sine of A, is to the sine of 17 degrees, as 20 centimeters is to the sine of B. Okay, and so angle B is up there. And so you're going to do your cross, multiply, and divide. Just remember, after you cross, multiply, and divide, that decimal that comes out is an angle B. It's the sine of angle B. So I'll try to do this here. Sine of 17 times 20 divided by 23. So I have sine of angle B is 0.25423. And then if I want to find out what angle B is, then that's when I'd use my inverse key. So I'll go sines inverse of that answer. And it turns out to be 14.7 degrees. Angle B is 14.7 degrees. Okay? So, now don't make it hard. You know all three angles after 180, so you don't really have to do law of sines or whatever okay? But the law of sines are slick. Okay? Now there is one case, and we've talked about this before, that can sometimes be a problem. And that's whenever you're given a side, and an angle. Okay, or something, you know, last year I think I wrote it like that. I mean, we talked about why you can't do angle side-side. Okay, so I'm going to do an example of a side-side angle problem, and just kind of the way I approach it. There's different approaches. This is the way I usually do it. So this is just example 4 off of page 262, if you're wondering. I'm given a thing. It says side A is 6, says side B is 8, and I'm given an angle A of 35 degrees. Okay, so right away, when I see this information given, side angle, I should really kind of, in my mind, have bells and whistles goes off, because there's really 3 things that can happen. When you're given a side angle, there could be one answer, there could be one triangle that results, or one set of answers. There could be 2 triangles that result, or there could be no solution, empty set. Okay, if you're given that information, sometimes that happens, and so maybe I should draw each of those. So the one triangle situation would be, okay, I'm given an angle, this side, and this side. Angle, side. And they all work out so that it's perfectly, there can only be one thing that happens. It'd be a right triangle. Okay? Or you could get the 2 triangle case where you say, okay, I'm given an angle again. Okay? So I'm given this angle, I'm given this side, and I'm given this side. But guess what? This side, maybe it's a certain length, could make the triangle that way, but it also could make a triangle that way. So there's actually, with that same length, I could make 2 different triangles. And then the third case would be, okay, I'm given an angle, and I'm given a side, okay, and I'm given another side, but that other side's not even long enough to reach to make a triangle. So there's no triangle there. So how do you know what you're dealing with? This is what I do. Okay, so this, like I said, this is example 4 off page 262. I just draw it. Okay, so I got about a 35-degree angle. I don't know, is that 35 degrees? I'm going to call this A. Okay, and if this is A, I'm going to make this side 8, and I'm going to call this B. Okay, now here's what I do. I know that they gave us side A is 6. Okay, side A is 6. So that means, you know, side A is it 6 this way? Is it 6 this way? Is it straight down the middle? Is it even long enough to make a triangle? So before I put that in, I kind of do a separate problem. I just say, okay, the shortest distance from where side B ends to here is this straight down thing, like the single case situation. I'm going to find that length right there, that like it was a right triangle, and that will kind of help me know what I'm looking at. And see, this isn't hard to do because it's a right triangle. Now I say, well, I'm looking for the opposite. I know the hypotenuse. That's sine. So I say sine of 35 degrees equals the opposite, which I'm asking about, over the hypotenuse, which is 8. Okay. So then you cross, multiply, and divide, and you take, okay, the sine of 35 times 8 divided by 1, which doesn't change anything. And I find out that if this thing went straight down, it would have a length of 4.5886. Well, here's the deal. Side B isn't. Oh, sorry, guys. That's bad. Not that bad. Hopefully, I don't know how far I need to go back. What I said is, okay, I have angle 35 degrees. I have side B, which is 8. And then I figure like it was a straight, perfectly right triangle. And I set up a little sine of 35 is 1 over 8. And I found that if side B was 4.5886, it would be a perfect right angle. But here's the deal. My side B wasn't, not side B, side A. My side A wasn't 4.5866. My side A was 6. Well, what that tells me is I have a 2-case situation. 6 could come back in here, or 6 could come back over here. Those are my 2 triangles. Okay, I have 2 triangles. So, and maybe I'll even draw them separately. So I have this one. This is 8. This is 35 degrees. And I have my 6 going off in that direction. And I should probably label my sides. A, this would be little a. B, this would be little b. C, this would be little c. okay? And you can do the law of sines on that triangle and find the solutions. But if you drew the other situation, oops, I made that too long already. Let's start again. If you do the other one, angle A, still 35 degrees. Side B, still 8. And side A is 6. But instead of having it go out this way, there's nothing that says it can't go that way. Okay? And then let's see if that's angle B. And that would be your angle C. And you could solve this triangle. And you can see that the exact same side, the exact same side, and angle, side, and angle given. I get two different solutions. So that's the tricky case when you do the law of sines, the side, angle. You kind of, like I said, I go through what would it look like as a right triangle, and I say, hey, if A is, if A was 6, I can get 2 triangles out of it. What if A had only been 3? I wouldn't have got any triangles out of it because it takes 4.5 whatever to actually get back down there. All right. I think I'm going to stop this video because I kind of been going a while and maybe make a separate one in another day for section 4.3, the law of cosines. Here's your assignment for section 4.2, the law of sines. It's going to be on page 265, and it's going to be 10 through 40 multiples of 5. So once again, instead of doing every other even or something like that, we're kind of spreading it out a little bit. So we'll go multiples of 5. So like I said, the video is getting long. I think I'm going to stop it. I hope you're doing your work. Hope you're staying safe, and get stuff done and send it to me via email. We will Zoom at 10 o'clock every morning if that still continues to work for you guys.